What's up, Algebra 1 students? Mr. Jagler here. We're going to get started with our first ALEKS topic for the week. We're going to talk about something called the basic counting principle. And I'm going to go through about 3 examples on the screen here. Feel free to take notes, pause, rewind, fast forward, anything you need to do to understand it. After we go through the examples, feel free to either go back to Google Classroom and click the link for the second video, or go to ALEKS and try to take down this ALEKS topic on your own. It is listed under Algebra 1 Week 1 in ALEKS. So let's take a look at the first problem here. It says, Peaceful Travel Agency offers vacation packages. Each vacation package includes a city and an airline. The agency offers 2 cities and 4 airlines to choose from. How many different vacation packages do they offer? So, first thing we're going to do is we're going to take our 2 cities. Now, if you want to get creative with it, you could pick actual cities. For me, because I'm boring, I'm just going to do C1 and C2. Now, from there, I need to match up each city with all 4 of the airlines. So what I'm going to do is I'm going to match up the 4 airlines with C1 and then do the same thing for C4, or sorry, for C2. Now, when I do this, what I'm creating is what's called a list of outcomes. So this column with all the A's in it over here, this is called the list of outcomes. And basically what you can see here is that there's a pattern that A1 is matched up with each city, A2 is matched up with each city, and so on. And if you take a look at the total number of outcomes that we have, and you add them all up, you see that there are 8 possibilities. So the question says, how many different vacation packages are there? That would be 8. Now, some of you may have caught on to this already. Some of you may have been able to figure this out without all this work over here. But what you can do to solve a counting principle problem is simply multiply your 2 and your 4 together. 4 airlines, 2 cities, multiply them together, and you get your 8 combinations. Okay, so let's take a look at another problem here. The first one we did had only 2 different categories. So if we take a look at the second one here, we've got a little bit different of a setup. It says the Flores family is selecting a furniture set. A furniture set has a bed, a desk, and a dresser. There are 3 beds, 1 desk, and 3 dressers to select from. How many different furniture sets could they select? So if I start off over here and list my 3 beds, the thing that's unique about this one is that we only have 1 desk to choose from. So we don't need to do more than 1 arrow coming from each bed because we only have 1 possibility for our desk. Now, we do have 3 dressers to choose from now. So we do have a third category here. So what I'm going to do is I'm going to extend my tree diagram a little bit, and I'm going to write each dresser in this column. So what you'll notice here, again, we have another pattern, but this time we have 3 different options for each of the 3 beds, which means that total we have 9 options. And if you see the pattern, what you're going to see is that these 9 sets, you could also find this by taking 3 times 1 times 3. So I got one more example here, and this one's going to have 3 categories as well, but this time we're not going to have a 1 here. Now we're going to have 2 beds, 2 desks, and 3 dressers. So the Davis family is trying to select a furniture set. So if I've got 2 beds, there's bed 1 and bed 2. I got 2 desks. Since I got desks and dressers, I'm going to write out desks so that's shorter. I got desk 1 and desk 2. And I got the same combination here for my second bed. Now, from each of these 4 possibilities, I have to take into account all 3 options for my dresser. So I'm going to call my dressers D1, D2, and D3. And if you take a look here, as I finish this up, you're going to go right back to having 3 different categories, but it looks a little different this time because I have that second desk. So if you finalize here your list of outcomes, you'll see that you've got 12 different possibilities. You've got D1 listed 4 times, D2 listed 4 times, and D3 listed 4 times. So that's 12 different sets of bedroom furniture. Now, again, you could take your number of beds, which was 2, times your number of desks, which was 2, times your number of dressers, which was 3, and you would get 12 sets of bedroom furniture. The counting principle is a cool thing because you can take any number of categories you want. If I extended this and say I was looking for nightstands, and there are 5 different possibilities for nightstands, I would just multiply by 5. And let's say there were 4 different possibilities for a lamp that you want to put in your room. You would just continue to multiply each additional category by the previous one. So that's what the basic counting principle is all about. If you need to rewind, feel free to do that. Otherwise, go to ALEKS, look up the introduction to the counting principle. If you are one of the lucky ones that's already done it, just move on to the next video. If you are one that doesn't have it unlocked yet, check out and see which prerequisites you need to do first. And if you're one of the people that has it unlocked right now, go in and look, search for it, see if you can get that topic done, and then come back here and get your second video for the day.